We are going to start the reactions of halogenoalkanes. There's a couple of reactions. We will see how these reactions can be used to illustrate, to discuss the halogenoalkane reactions with illustrations for better understanding. Our first reaction under halogenoalkane is the reaction with alcoholic sodium hydroxide and potassium hydroxide. Halogenoalkanes react with sodium hydroxide in alcoholic medium. Instead of sodium hydroxide, we can use potassium hydroxide also. This is a very, very commonly found out area in the paper. We'll see. These reactions produce alkanes. How is it possible? Here we have CH3, CH2, CH2, Cl molecule going to CH3, CH double bond, CH2 as HCl. I've drawn this structure using displayed manner. See this first compound? Here we have alpha carbon over here. This is alpha carbon, carbon number 1. In the diagram below, you can see alpha carbon over here. In these reactions, the chlorine atom is going to go away with a hydrogen, which is on a carbon atom next to alpha. So if this hydrogen and chlorine, if they go out as HCl molecule, each carbon atom here, the alpha carbon atom and the neighboring carbon atom, they are going to lose a bond each. So between these carbon atoms, a double bond is formed. This is a alkene. Remember, to do this reaction, we have to add sodium hydroxide, alcoholic medium, heat under reflux. These reactions happen under heat under reflux condition. And these reactions are called elimination reactions. Why are they called elimination reactions? Because this HCl is eliminated from the molecule. HCl is eliminated. When a halogenoalkane is heated with alcoholic sodium hydroxide, not aqueous, or potassium hydroxide under reflux, a hydrogen halide molecule gets eliminated, forming a double bond between carbon atoms. The hydrogen atom and the cornermost chlorine in this molecule, shown in yellow circles in the above example, get eliminated, producing only one alkene. What is the meaning of producing only one alkene? It means there can be reactions where many alkenes are formed. However, if the hydrogen atom appears on the carbon atom other than in the cornermost carbon, again, however, if the halogen atom appears on a carbon atom other than the cornermost carbon, in this case, chlorine is on the cornermost carbon. If you have chlorine in a cornermost carbon, you get only one product. But if chlorine comes to a middle carbon atom, then there is a possibility of getting maybe at least two reactant product molecules. The halogen atom and the cornermost chlorine, the hydrogen atom and the cornermost chlorine atom shown in yellow circle in the above example get eliminated, producing only one alkane. Alkane is shown over here. However, if the halogen atom appears on a carbon atom other than the cornermost carbon, Several products can be formed as discussed below. Okay, alcohol lesson, let us not touch it yet. We go to an example here. Look at this. This halogenoalkane is 2-chlorobutane. 2-chlorobutane. There we have chlorine on the second carbon. Chlorine on the second carbon. And I'll write 3 also. Second carbon is an alpha carbon. On the left-hand side, carbon number 1. On the right-hand side, carbon 3. What happens is this. There are 2 reactions I can show. This chlorine can go with the hydrogen on the third carbon. If it goes with the third carbon, double bond appears here. Butene. However, if the chlorine goes with the hydrogen on the left-hand side, then the double bond appears in the first carbon. It is butene. Now, it looks like we have only 2 products. Actually, no, there are 3 products. From this compound, we can have cis trans isomers also. Note, but1-ene cannot show geometrical isomerism. But but2-ene can show geometrical isomerism. We see these compounds, the geometrical isomers of this C here. CH3 hydrogen, CH3 hydrogen. Same thing is on the other side also, but only difference is in the second compound the hydrogen and CH3 have been switched. So the compound on the left-hand side is trans. The compound on the right-hand side is cis. So altogether, in this reaction, there are 3 compounds formed finally. 3 compounds are formed. Let's try to use the knowledge that we just discussed about reactions of halogenoalkanes with alcoholic sodium hydroxide heat and reflux to find the answer for this question. How many different molecules can be formed when each of the following halogenoalkane is heated with alcoholic KOH or NaOH through their structure? To understand what happens here, it's always better to draw the structure at least to some extent in a displayed manner. I will write CH3, this one, and there's a CH2 part. I will draw it in this manner. And then carbon, CH3. The CH3 can be shown in this way, CH3. And Cl, we have Cl here. And then CH2 and CH3. How many different types of elimination products do you think can be obtained from this reactant? Roughly how many? 1, 2, 3, 4. First, I will remove this chlorine with the hydrogen on the left-hand side. And that gives me the product between these carbon atoms, a double bond is formed. And on the left-hand side, there's a hydrogen and a CH3. On the right-hand side, we have this CH3. Down here, CH2, CH3. It is if the chlorine goes with the hydrogen on the left-hand side. If this chlorine goes out with the hydrogen up there, hydrogen and chlorine, then what will happen? All right, CH3, CH2, here we have one carbon, CH3, CH2, okay, CH3 up there, not CH3, because I'm showing this chlorine going with that hydrogen. So this is going to have only two hydrogen atoms. One hydrogen there, one hydrogen here, and a double bond. CH2, CH3. For this compound, I can draw its geometrical isomer, carbon, hydrogen, CH3, double bond, CH3 is over here, CH2, CH3. Three compounds are formed. 1, 2, 3. Okay, assuming that you understood this concept, I want you to do the next compound over here. Yeah, only one compound is there. You can try it out at home and see how many different types of alkenes can be formed from this reactant here. That's about the first reaction. Now I go to the second reaction. The first reaction is about reacting a halogenoalkane with alcoholic sodium hydroxide. Now I go to a condition where we use aqueous sodium hydroxide. The difference is in these reactions, alcohols are produced. Alcohols are produced, and these are called hydrolysis reactions. When a halogenoalkane is heated with aqueous, remember, aqueous sodium hydroxide or potassium hydroxide under reflux, the chlorine atom goes out and an OH atom comes into that. See, chlorine has been removed and OH has come in that place. In the second one, we have iodine. This iodine goes out and OH comes in. In the next one, we have bromine. This bromine goes out and an OH comes in. These are all hydrolysis reactions. Sodium hydroxide, aqueous, heat and reflux. Same reagent, but when you use conditions differently, we get different products. These are identified as hydrolysis reactions. Next, we go to the third reaction. Reaction with alcoholic potassium cyanide. Reaction with alcoholic potassium cyanide. These reactions produce something called nitrites. Let's see how a halogenoalkane CH3, CH2, if it's a chloroalkane, how it is going to react with cyanide. Usually we use KCN. The product will be CH3, CH2, CN. The product over here is chloroethane. And this is a special type of reaction, compound. This is called propane nitrite. Propane nitrite. This chloroethane has 2 carbon atoms. But propane nitrite has 3 carbon atoms. Here in this cyanide part, there's a triple bond. CH3, CH2, carbon triple bond nitrogen, a nitride. We can do this reaction if you use potassium cyanide is alcoholic medium, heat under reflux. Chloroethane react with Kc in alcoholic medium when heated under reflux to produce a compound called nitrile. Because this nitrile has 3 carbon atoms, we call it propane nitrite. It's given in detail in the note. Reaction with alcoholic potassium cyanide, KCN. These reactions produce nitriles. I just showed it to you. And some examples for nitriles to become familiar. This is a 2 carbon atom containing nitrile. So it is ethane nitride. This one has 1, 2, 3, 4 carbon atoms. So butane nitride. And the next one is propane nitride. These are also nucleophilic substitution reactions. When a halogenoalkane is heated with alcoholic potassium cyanide, I wrote here alcoholic, yeah, alcohol. The halogen atom gets replaced or substituted by a CN group. See, CH3, CH2, Cl with 2 carbon atoms change to CH3, CH2, Cn. This should be Cn. It has 3 carbon. If you react this 3 carbon halogenoalkane, CH3, CH2, CH2, Cl, it goes to CH3, CH2, CH2, Cl. It's a nitrile with 4 carbon atoms, whereas the reactant has only 3 carbon atoms. It's about halogenoalkane reaction with potassium cyanide. A halogenoalkane molecule undergoing nucleophilic substitution with cyanide group in SM2 mechanism, forming a nitrile molecule. You can see in this mechanism, cyanide group gives electrons to carbon, which has a positive charge, slight positive charge. And chlorine goes out. It's the same thing. Chlorine goes out. Here we can see transition state. Chlorine going out, cyanide coming in. Finally, the chlorine has gone out as a chloride, cyanide group has been added. This is an important reaction where the carbon number of a molecule increases by 1. If afterwards, There's one more reaction. See, this is CH2, CH3, CH2, CN. CH3, CH2, C triple bond N. This compound can be reacted with first one an acid. You add an acid and heat it. What happens is the alkyl group CH3, CH2 remains constant, but cyanide group becomes COOH. At the same time, if you use a reducing agent for this, like hydrogen, nickel catalyst, and heat, you will get CH3, CH2. For this cyanide, I can write it goes to CH2, NH2. This is an amine because there's NH2 part, amine. So this halogenoalkane has gone to an amine. There are 4 reactions. Yeah, a halogenoalkane can be reacted with an acid and heat to get carboxylic acid. If a compound like this reacts with hydrogen nickel, you get amine formation. If a nitrile is heated with dilute hydrochloric acid with an acid, the cyanide group gets hydrolyzed, forming a carboxylic acid and N, cut this D. It's okay. Carboxylic acid and ammonia gas. Equation is given. CH3, CH2, Cn goes to CH3, CH2, COOH, ammonium chloride. Actually, this sort of reaction will not be expected in the exam. At the same time, when a nitrile is reduced, reacting with either hydrogen at the presence of nickel catalyst and heat, or lithium aluminum hydride. See what happens. CH3, CH2, Cn go to CH3, CH2. The cyanide goes to CH2, NH2. Please remember these things. Okay. Reaction with ethanolic concentrated ammonia is the next one. I hope you understood this concept. In the next session, we will discuss the other reactions of halogenoalkanes, plus we can discuss some questions. So I think I want to stop this session now. Thank you very much for coming to the lesson, and see you soon.